This is often done in something called a proposition bet, where somebody will ask you to put up money and then try to take the money away from you. But in this case, we're just doing it with these little tokens to kind of show it. So I've got a glass there, right? It's just an absolutely normal, ordinary glass. Which is longer? The distance around the circumference of the glass, okay, or the distance from the table to the top of the glass, okay? So I've got a sheet there, so that side says circumference, that says top to table. Can you please put your coin down on which you would guess is right? So if you think that it's longer around the circumference, you'd put your coin there. If you think it's longer, more of a distance from the bottom of the table up to the top of the glass, put it there. So can you put your tokens where your guess is? Okay, so most people are going for table to the top, but you're going for circumference. Right, okay. Pack of cards. I ask the same question. Further around the circumference or from the bottom, from the table to the top? Do you want to change your bet? No. Right, rest of you obviously don't want to. Another pack of cards. Ask you the same. Circumference or table to the top? What do you think? Are you wondering? It's up to you. Where are you going to put your guess? You're going to move it? You're going to leave it? Okay, another pack of cards. Circumference or table to the top?
Circumference.
Circumference? What do other people think? I mean, what do you guys think? Really? 3 packs of cards there? Make it 4. This is getting silly. Circumference or bottom of the table, top of the glass?
Circumference.
Circumference? Last thing I can do, packet of post-it notes. Are you serious? Circumference or table to the top?
Circumference.
Circumference. Look at it. Absolutely. How could it possibly be the circumference is longer than that? The majority of people, not surprisingly, go there. If I take this piece of string and I put this piece of string around the glass, you can testify that's tight round it. That is the circumference, which is now stuck under the lip of the glass. Okay, I then put that on a ruler, and again you can testify that the length from the bottom of the ruler to that post-it note is the same as that piece of string. Yep. And I take this, I could actually probably have stuck another post-it note under it as well, and it would still have won. So the circumference of the glass is in fact longer than it is from the base of the table up to the top of the glass. And that's really amazing. People will put lots of money, will make lots of guesses based on that, particularly when you're able to go like that and add the parts onto it. It just seems quite impossible. So, why? What's the formula for the circumference of a circle? Yep.
Diameter times pi.
Pi, correct. And what's pi roughly equal to? Yes.
3.14.
Correct. So it's about 3. So the circumference is actually 3 times the diameter on there. But the reason this trick works so well is that not only do you have this part to it, but it works on a beautiful optical illusion. Okay? So your circumference is the diameter times pi, right? Look at this shape over here. This is called the T illusion, the T optical illusion. Is the T longer in this direction or in that direction? Okay, in this direction, yeah? But that's the optical illusion, because that line and that line are in fact exactly the same length. But the way your brain does the mathematics inside its head to work out distances, and because of the way that your environment is around you, you tend to see that as being longer than that. So these two things combine together, because in effect, when you're looking at a glass, the height and the diameter in there are like the parts on the T shape, okay? So you actually see that diameter as being smaller than the length of the glass from the top to the bottom. Combine that with the fact that you've got 3 times that diameter, which your brain is seeing as being much smaller than it really is. 3 times that diameter because you've got c equals pi d in there, and that's why the trick works. The trick works a combination of mathematics, which you know, which is the circumference formula, but also because of the way that your brain is actually calculating information inside your head.